Here we tessellate a surface with different patterns, and for each distinct pattern we color the surface polygon with a distinct color. Having defined the desired patterns, the tool generates a corresponding reduced pattern tessellation, which can be here seen in cyan. Now the user can start defining simulation scenarios by defining boundary conditions and loads on desired nodes. Rigid vertices are enclosed in red spheres, and external forces are depicted here in red. The tool automatically maps the simulation scenario to the reduced tessellation. The user can now instantly compute the reduced simulation result of the defined simulation scenario and iteratively edit the defined scenario to alter the results. Here the user adds some opposing forces at the opposite side and recomputes the reduced simulation. The user keeps editing the simulation scenario by introducing new forces and reevaluating every time the reduced simulation to evaluate the deformation of the structure. The user now further constrains the structure by fixing additional nodes and recomputes the reduced simulation. Now the user decides to flip the defined forces on the surface and reevaluates the reduced simulation. When the user is satisfied with the deformation of the structure, he computes the actual nonlinear simulation result of the tessellated patterns, which you can see here in black. We overlap the reduced simulation results with a true nonlinear pattern simulation in order to observe the approximation error. The user can additionally load a pattern tessellation and a scenario that was previously saved. In this scenario, the user applies a set of increasing moments, which you can see in yellow. The arrow represents the moment's axis and relative rotation. The red spheres represent rigid vertices and the red arrows external forces. The scenario is automatically mapped to the reduced tessellation. The accurate nonlinear simulation results are here depicted in black. We additionally show the reduced simulation results in order to demonstrate the accuracy of the method. In this case, we randomly tessellate the surface with a distinct pattern for each polygon. The user defines a new simulation scenario on the tessellation of random patterns. We show both the reduced simulation results and the nonlinear pattern simulation to demonstrate the accuracy of the approximation. We randomly tessellate this input surface. In this case, we saw the applicability of our approach to a bigger tessellation. The pattern tessellation in black is mapped to a reduced tessellation in cyan. Each distinct color represents a different embedded pattern in the polygon. We apply a random scenario and instantly get the results of the reduced simulation. This pattern tessellation contains more than 50,000 edges.